Here's the next project. This is a tube portable radio. And this is the way I found it. The handle's missing. And okay. Push that in. Ugh. Looks like it's stuck. Let's see here. There we go. It is stuck. Let's see. Well, this will work. There we go. Okay, you can see the antenna. And looks like the plastic has shrunk quite a bit, and that's why it pulled away, but that's what the front of the radio looks like. Let's see, and it's a Regal. It's a model 747. Put this over here, and I decided to start working on this, so I have to close this. Open up the back here. Okay. There we go. Portable 747 AC/DC tube type radio, and you can see that that has kind of expanded, and there's loose wires in here. So it's time to find the wiring diagram. This is the wiring diagram of the radio, and it's a very typical super heterodyne setup. You see 4 tubes there, and if you look in the lower right hand corner, if you follow the plug over, you'll see the rectifier there. That's actually taking the job of one other tube. They're just using a solid state rectifier here. Now if we take a closer look, I want to go through the signal flow in this radio. It's been a while since I did that. So if we take a closer look at this and at the antenna all the way to the left, when we have this tuned to a radio station, its RF signal is received by the antenna, and that signal is fed to the grid of the 1R5. Now we're going to have another signal from the oscillator, and that is going to mix together, and we're going to get several frequencies, but the one that we're going to pick off is the one that is 455 kc. That is the IF frequency, and that is what the IF cans are tuned to. So this signal is now magnetically coupled to the secondary and goes over to the grid of the 1T4, where it gets amplified, and then to the primary of the second IF can. This signal is magnetically coupled to the secondary, and that signal then goes over to the diode plate of the 1S5. Now if you take a look at the bottom part of the secondary, notice that it's going over through a capacitor and down to ground. This is where the unwanted 455 kc signal is grounded or drained away. What we're after here at this point is audio. And if we didn't drain away this 455 kc, it would distort the audio. In other words, we don't want the 1S5 to amplify the 455. We're wanting the 1S5 to amplify audio. And something else that's going on here is that this is our audio, and it is getting rectified from the diode plate of this tube, where the secondary is, to where the filament is. But if we take a look at this tube 1S5, pin 1 is actually grounded, and we can see that in this diagram here. If we take a look at 1S5, we can see that pin 1 is grounded through a 560 ohm resistor. So what we actually end up with as far as signal tracing goes is this. The 455 kc is being drained away. The rectification gives us an audio signal now, 1/2 of an audio signal, and that is going down from the secondary through a resistor to the top of the volume control. And you can see the 0.01 microfarad capacitor. As that pointer goes up, the volume increases. Now this signal is fed over to the control grid of the 1S5. It gets amplified, comes out the plate, and notice that there's another capacitor that drains off any RF that's left over. That audio signal continues over to the control grid of the 3S4. Now the 3S4 amplifies this audio signal. It comes out the plate and over to the output transformer that drives the speaker. Now let's go back to the secondary of the second IF can. There's another signal there that we should be aware of, and it is a negative DC signal. That capacitor down at the bottom, that .05, is storing the AVC voltage, automatic volume control. So when the audio is high, a little bit of that signal is fed through a high resistor and stored in that .05 capacitor. So that capacitor, its polarity is the ground is positive and the other side of the capacitor is negative. Now this negative voltage, if we go over to the left, you can see goes to the grids of the 1R5 and the 1T4. So the louder the audio is at that point at the secondary of the second IF can, the more negative that capacitor becomes, and that tends to turn down the first two tubes. The more negative the grids get, the less those tubes will amplify. Likewise, if we run into a weak station, the audio will be less. The negative voltage stored by the .05 capacitor will be less, and the first two stages will amplify the signal more. Here are some still shots of this radio. This is the front of this 747 Regal radio. And here's the back, and here's a closer look at the sticker. Here's a look at that antenna. You can see it's just a loop of wire. And here I've started taking out the batteries. And here's a closer look at that battery that's swollen up so bad. I had some struggle getting it out. But in this shot you can see that I did get it out. I had to take it out in a couple of pieces. And here's a closer look at those batteries. So I'll continue on with this restoration. I'll do some more testing and I'll tell you what I find. I'm going to check all the coils, check the tubes, and if that passes the test, I'll start changing out capacitors and we'll get back to you and let you know what we find with this radio. Thanks for watching.